Hello and welcome to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of the York University Observatory. You can now find us wherever podcasts are distributed. I'm Mary Armour, one of your hosts this evening, and I am joined by Patrick Hall. We are broadcasting live from the Allan Carswell Observatory, located at the Keele campus of York University in Toronto. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal time from York U Observatory. We also run in concert with our online public viewing, or as we call it, OPV. This is the feed run by the observatory staff, where we can either do live online observing or, as tonight, where the weather is not particularly great. I believe they are mainly going to be showing archival images during our podcast, right? To navigate to our light show or to find out more about us, please check out our website at yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube, where we do always have people answering questions. Any questions or comments you have on past shows or suggestions for future topics, send them to our email at observe@yorku.ca. You can always connect with us on Instagram with the handle @YorkU Observatory or on Facebook at the Allan I. Cars Web Ob. Okay? Our programs are free, but if you'd like to make a donation, we'd certainly appreciate it. And there is a link on our website. And again, we are always monitoring the chat on YouTube for any questions. Okay. Hi Pat, how are you today? Uh,
Hello, I am here and now unmuted. Sorry for that delay.
yeah, always the joy of doing anything online. You mute yourself to be polite, but forget to unmute when you need to talk.
Exactly.
So,
So yes, despite the cold weather, we got our observatory dome working again. So we got some observations over the weekend, and I expect some more this week.
yeah, the weather has not been kind to the observatory this past week, that is for sure. Domes do not like a lot of snow and ice. Yeah.
No.
So, but sort of moving on to some of our this week in space and astronomy history, I think you had one about another telescope that was probably very unlikely to have experienced any kind of snow or ice.
Yes, I don't know. This is the Hale telescope, the 200-inch diameter telescope at Mount Palomar in Southern California, which we're talking about because on 26 January 1949, it had its first light. And this was the world's largest telescope for nearly 30 years and second largest for nearly 25 more. So I don't know that, I don't think they may have escaped some snowy weather. California's gotten a lot of snow and rain this winter, so they may have gotten some snow as well. So this Hale telescope, 200 inches in diameter, just a solid hunk of glass. Its first observation was known as Hubble's Variable Nebula, or NGC 2261, which is really cool. This is a nebula illuminated by the star R Monoceros, but the light reaching the nebula varies. So if you look on Wikipedia for Hubble's Variable Nebula, you'll see this neat animated GIF. And the current thinking is that dust in between the star and the nebula dims the light reaching it by an amount which varies with time. So this big nebula actually flickers over time, despite being much bigger than the star. So that's pretty cool. And the Hale telescope is still in regular active use today. In fact, my former graduate student and a postdoc and myself were allocated telescope time on it, like one night or perhaps half a night, but the weather was unfortunately cloudy. So we didn't get any data, which is the curse of astronomy, but that's okay. So happy anniversary to the Hale telescope.
Yeah, it was quite spectacular at the time. And if you think in sort of modern technology standards to be sort of the largest for 30 years and then the second largest for another 25, that's a pretty spectacular run of time. If you think about it, I mean, more than 50 years. So at 2004, it was finally knocked off of second place. That's a pretty spectacular run for technology in this time period.
I
So,
think it was in the 1990s, but yeah, even so, it when you, as you said, when you think about it today, that if let's say around 2000 it was knocked off, um, by 2030 there's going to be this extremely large telescope which will hold the record for the biggest optical telescope for the foreseeable future. So yeah, having those many decades at first or second biggest in the world, that's going to be tough for anything to match until the extremely large telescope gets built.
yeah. It's kind of neat how, like you can even build a telescope that big. And if you think, 1950s technology, that was probably even a bigger challenge than it would have been nowadays. You simply don't see telescopes that big. So,
Yeah, it's true. It's uh, 5 meters in diameter roughly, and that's pretty impressive. I think we may have a little more to say about big telescopes later in the podcast.
yeah. Yeah, so the other sort of update, no, won't call it history, but history in the making. Of course, one of the things that is coming along is this whole Artemis mission. We're sort of right in the middle of the process. And of course, this coming Sunday is when they are planning to launch a four-person crew that will hopefully be able to launch on Saturday. It's already been pushed back a bit due to this extremely cold weather we are having. Even Florida has been affected by it, which is quite unusual. But it's made it sort of unsafe to launch at least until Sunday. And I don't know, I figure there's probably a good chance it'll be pushed back even farther. Uh, and after the Challenger disaster, of course, they've got much, much stricter about monitoring weather and not launching, particularly in cold conditions.
Yes, they
Um,
will definitely err on the side of caution.
yeah.
And with iguanas falling out of the trees in Florida, I think you're probably right that there may be another delay.
Yeah, I mean, they're hoping, I mean, the launch window runs until April, so they have quite a bit of time, and it seems unlikely, that this cold will extend that long. But it may be challenging to actually get it off the ground this time. But it is in the news quite a bit. The one very disturbing article I saw about it is some people are a little bit unsure about some of the technology. Um, and there's some debate that they're rushing the safety of this thing, which worries me. That's an article, I've read that article a couple of places in the last week or so. So I don't know. Between the cold weather and some of these other things, this could be a interesting situation that arises. I mean, I hope they manage to launch it, and I hope they manage to go through a flight successfully. But there are a lot of challenges with this one. So, I mean, they're aiming for what, a 10-day mission on this one, in hopes of being able to land back on the surface in 2028. So it's quite an important part, and hopefully it doesn't get delayed too much, because if this gets pushed back, everything else gets pushed back as well, of course. So,
Yeah, I certainly think they'll have a chance to launch before April in terms of weather, but let's hope there's not some uh, technical problem that's found that they want to, roll things back to the
yeah.
barn, so to speak, and repair it.
Yeah. So, yeah, I mean, NASA's record overall has been very, very good for launches. They haven't lost many crewed spacecraft, but they have lost a few. And I think your next sort of item brings that one up.
Yes, if you look back at the testing that NASA and even the various private space companies have done, there are a lot of test failures, but they gradually work things out so that by the time they're launching crewed missions, the safety is quite good. So let's hope that continues. But there is an unhappy anniversary this month. Excuse me. Getting getting choked up about it just a little. So February 1st, 2003 was the day that the Space Shuttle Columbia was destroyed while returning to Earth from an orbital mission. So it broke apart at an altitude of about 40 miles, and all 7 crew members on board were killed. And this occurred because during launch, there was a piece of insulating foam that broke off from the external tank where the fuel is stored, and it struck the heat protection tiles on the orbiter's left wing. So this had occurred before during previous space shuttle launches, causing damage that ranged from minor to near catastrophic. So I guess there had been some similar incidents in the past where they escaped destruction of the spacecraft, but perhaps not by as big a margin as you would want. So it took more than 2 years before NASA was willing to launch again, very similar to after the Challenger disaster. So the International Space Station construction was paused, but in July 2005, flights resumed, and NASA made some changes to subsequent missions. So they had an on-orbit inspection where they would just take a look at the heat tiles on the fronts of the wings and make sure that there was no serious damage that would prevent the spacecraft from returning safely to Earth. And they had designated rescue missions ready in case the damage was found to be irreparable. So that they would actually have another space shuttle on the launch pad or very close to launch, launch readiness. So there was one mission to repair the Hubble Space Telescope after the Columbia disaster, but everything else, I should say, all the other missions with the space shuttle were flown only to the International Space Station so that that could be used as a place for the astronauts to hang out if damage to the orbiter prevented it from returning on time. So I was at an observatory in Chile actually at the time, and I woke up after observing late to the news of this happening. So it's yeah, I can point to that memory and the memory of the Challenger disaster when I was in grade school, high school. Fortunately, there aren't too many memories like this for us. NASA does a pretty good job at safe launches with these few exceptions, but as I've said, they do take precautions once they learn what to look out for. Let's just hope that with the Artemis missions that they've thought of things in advance and have a good plan ready about scrapping launches if it's not the right conditions for a safe launch.
Yeah. It's like I said, I mean, Florida, the weather is generally, at this time of year, fairly stable. You're not in hurricane season, but, having spent a couple of winters down in Florida and actually seen shuttle launches when I was down there, um, the cold is very, very unusual to extend that far south. So it's a bit of an odd one. And hopefully there aren't any unexpected things that come out of it. But it would be nice to sort of get Artemis up and going and actually sort of get to the moon again. It's been interesting because I've seen some articles floating around too, like if we've been to the moon, why are we bothering to go back? But I'm like, well, yeah, it was 50 some years ago now, the first, 50 odd years ago that they first landed. So technology's changed a lot since then. There's probably a lot more we could learn. I mean, and there's always talk of a permanent moon base and all the possibilities around that. So, I mean, Artemis is kind of the first step. So the sooner we can get this going, the better. And
Yes, very true.
A lot of the technology out of the space shuttle program was very key in sort of what the design comes up for these newer missions. I mean, even the failures are helpful in plotting the further missions, right? It all still kind of ties together.
Oh, absolutely. And yes, the technology that they went to the moon with in the 1960s and early 70s is quite amazing that they were able to do that. And the scientific investigations that you could do now with the moon landing would be, um, yeah, just orders of magnitude more advanced.
Yeah. So I think I had one more truly historical item on this. And this is looking more at stars. And here we're looking at white dwarfs because, of course, it was about the end of January in 1783 and then again in 1872 uh, that, the first kind of white dwarfs were discovered. William Herschel, who made a lot of discoveries and a lot of observations, um, found the first white dwarf, 40 Eridani b, although they didn't really establish it as a white dwarf until the 20th century, because, of course, in Herschel's day, white dwarfs hadn't kind of been, speculated about. They didn't have sort of the idea of solar evolution the way we did now. But then in 1862, Alvin Clark Jr. actually discovered the white dwarf Sirius B. So these are kind of interesting steps because first they're the white dwarfs and second they're kind of interesting binary systems. 40 Eridani, of course, is a triple star system in the constellation Eridanus. It's relatively close to Earth because it's just over 16 light years away. Eridani A is, a reasonably bright star that's visible to the naked sky and has been known then for, thousands of years. But Herschel found Eridani B and C through his various observations, because he spent a lot of time looking at a lot of different objects, and was started some of the ideas behind stellar evolution with some of the things he talked about. Um, Eridani B was finally recognized as a white dwarf in 1910. Um, so, and then was recognized as the first one that ever had been discovered. So what are in these systems, these white dwarfs are interesting because originally they would have had to be a little more massive than the current visible star, because of course they've already gone through all their fuel and then sort of gone through the red giant and then shrunk down to that kind of white dwarf stage. So you have this sort of interesting process where now you've got this white dwarf left that originally was a larger star in that sort of binary system. Um, and it's kind of interesting if you look back at sort of the whole history of these things, because of course Bessel talked about Sirius's proper motion that indicated it was an unseen companion. And this is some of that same sort of idea of looking for gravitational shifts in the system or gravitational effects that have to be produced by a second body, which is basically the same way the Kepler mission worked to find extrasolar planets around other stars, except now you've got sort of a second, much smaller body than that white dwarf. So it's kind of interesting that, like this technique, we first used it on white dwarfs, and now we're using it on extrasolar planet. Um, so as like I said, these were first observed in sort of the late 17 and into 1800s. And then later, when the technology got better, they were able to take spectra of them. And then, you had further Hubble telescope observations in 2005 to sort of actually sort of get more detail about these white dwarfs. Um, Sirius B, of course, Sirius being the dog star, you'll sometimes hear the nickname the pup applied to it, which is kind of funny. Um, but
Yeah,
Sirius,
I think
yeah,
it's remarkable this, you know, over a century. the star sitting there and then finally recognized to be the white dwarf. I had no idea that the first white dwarf was discovered that long ago.
Yeah. Well, it's interesting because some of these things were discovered and people sort of realized something was there. And yet it's not until much later that you actually sort of identify it and sort of the full understanding comes. It's interesting to look back at the records. I mean, the one I always think of when it comes to these sort of, well, someone observed it but didn't know what they were seeing, was Galileo and Neptune. I mean, Neptune was officially discovered in the first half of the 19th century, around 1830. But when they went back through the records, they realized Galileo had actually observed it over a couple of nights and sort of recorded it, and then he sort of lost it and never found it again. But it tracked exactly where the orbit of Neptune should have been. So we sometimes observe things well before we can identify what exactly they are, but that sometimes makes looking back through some of the old astronomical historical records kind of interesting because you can pick these things up. If you had good record keeping, whether it was sort of Herschel in 1783 or Clark in 1862, they didn't really know what they'd discovered, but they found something. And then later into the 20th century, we realized what they'd actually found. So
Yeah.
it's like I said, science is that process. It's not this, oh, aha, I found the first white dwarf. It's like I found something, and years later they kind of realized, oh, he actually found a white dwarf. That's kind of neat.
Yes, I had that happen with an unusual quasar I discovered. I published it, didn't really know what it was, but said, hey, this is weird. And then someone came along 10, 15 years later or so and had figured it out. I was like, great, neat.
And
And
I don't think,
I
yeah,
was
go
going to
ahead.
say, I'm reminded that Galileo also, he observed the rings of Saturn, but he didn't figure out they were rings. He couldn't figure out what they were.
Yeah. It's like I said, people sort of think of like these Newton and aha moments, and the apple hits him in the head, and suddenly he has like his whole theory of universal gravity. But science doesn't quite work that way. And there's a lot of these. I mean, especially in a science like astronomy, it's like people find something and they record it and they observe it, but they don't really know what they have, sometimes until, decades later in some of these cases, right? So uh, and as I said, Galileo made so many observations, but he didn't figure out what everything he saw was. And then later people used his observations to do it. So it's always kind of interesting when you have these sort of historical discoveries, but it takes time for the science to catch up with what are we actually observing. So
Yes, very true.
and I think it'll be interesting as Vera Rubin gets going to see how many other things we find, and then we have to figure out what they actually are. So yeah.
Yes, I was saying to my class that right now there's a class of objects known as FBOTs, fast blue optical transients. And that's simply a description because we don't actually know what they are.
So yeah, I mean, I still remember reading about the original discovery of pulsars, and they didn't quite know what they were, other than they were extremely regular. So they originally called the first two LGM1 and LGM2 for Little Green Men 1 and Little Green Men 2. And I'm like, yeah, it's a bit of a dangerous name because, people who don't understand science humor might take that a little too seriously. Um, But it's like I said, they found them. It just took them a while to figure out what exactly it was they were looking at that point. So it's kind of interesting how many examples of these we can find in history. And it's like guys like Herschel did so many observations, even if they didn't know what they were looking at, and then sort of started the whole process of, you know, figuring it out later on. So I think we're getting close to halfway. So just a few reminders. We are still running our regular observatory tours. Our next one is this Wednesday, February 4th at 6 p.m. And they continue weekly through the winter, except for Reading Week at York, which is February 18th, because that is our reading week. We won't be doing a tour that week. But you can check our website online to book a ticket. The tickets are entirely free. It's just so we have some idea how many people are coming those evenings. Also online, just a reminder, we still have our 2026 Observatory calendars available. We're selling them for just $15. They are great images, and even once the calendar is done, they've got some great photos that you can kind of cut out and use as little posters as well, which I've done many times with calendars where I love the images, but it's okay, the calendar's done, but I'll still have these great images I can use. Um, this calendar is sort of entirely produced by sort of the students and alumni of the observatory, so it's a great thing to get to help, support the observatory. So
And
in this, yep.
I was just going to say, I'm looking forward to our Groundhog Day theme. If you wait long enough, your calendar will work again, that the same dates will be on the same days of the week. It's 11 years, 17 years, something like that.
I think it's erratic because of leap years, but
Very
yeah,
true.
it's everywhere. It's like I said, it's somewhere between that 11 to 17 years, depending on where the leap years happen to fall. So, moving on until news, then I think you had some interesting ones looking at cold dark matter.
Yes. So this follows on from your mention of using gravity to study, um, to find companions to other stars and now planets around other stars. Well, there's other things we can do with gravity. So this is a story that's just come out in the past few months about what I would call the latest possible challenge to cold dark matter. So cold dark matter is the theory we have for describing how structure forms due to gravity in our universe. So we know that dark matter exists, but we don't know what it is. And therefore, theorists are very interested in testing the reigning champion of cold dark matter and trying to poke holes in it and find if there's a different theory that they might be able to explain and gain plaudits and Nobel Prize or two for it. But cold dark matter has explained most everything we see, even though we haven't actually detected the cold dark matter particle yet. And this story centers on a million solar mass object detected through gravitational lensing in 2025. So what is gravitational lensing? Well, it occurs because mass distorts space. So you may have heard of the analogy of space as a rubber sheet. If you get a bunch of people together and hold a rubber sheet off the ground, then you put a bowling ball in the rubber sheet, then shoot marbles across the sheet. Those marbles no longer travel in straight lines like things do in space when there's no mass there. You put the mass of the bowling ball on the sheet and you've distorted the path the marbles take on the rubber sheet. And this is an analogy to how our sun uh, distorts the path of the planets around it. If the sun wasn't there, as Newton told us, everything would just move in our solar system would just move in a straight line with constant velocity. But the sun distorts space, and the Earth orbits around the sun, and the other planets do as well because of this. But that's actually not the greatest analogy. It's good enough, but a better analogy is take this rubber sheet, cut out a long, thin section extending out from where you're going to put the bowling ball and stitch it back together. So it's still a 2D surface, but now there's literally less two-dimensional space around the location of the mass, and that distorts the paths of the marble. And in our 3D universe, there's literally less three-dimensional space around massive objects. So that means that if you look into space very near a massive galaxy, and there just happens to be a background object behind it, well, all the light emitted into space by the background objects is still out there. But there are regions where multiple magnified images of the background objects are produced. So all the light is emitted into space, but near a massive object, the amount of space is actually lessened. And so that light sort of doubles up. and you get these magnified images, which are typically stretched out into arcs. So if you search for gravitational lensing, you'll get some lovely images from the Hubble and the James Webb Space Telescope. But in this case, this source is known as JVAS for the Jodrell VLA Astrometric Survey, Jodrell Bank in the United Kingdom, and the Very Large Array in New Mexico. So JVAS B 1938 plus 666, I'm just going to call it JVAS. It's an extremely thin radio arc that has occurred because there's a radio hotspot, a radio galaxy, an object emitting gas from its active nucleus that then flies out into space at nearly the speed of light and forms these radio emitting blobs. And one of these blobs has been lensed into a very thin arc that we can image to very high resolution using very long baseline interferometry, which means taking radio telescopes around the world and turning them into a telescope as big across as the radius or the diameter of the Earth, and that gives us extremely high resolution. A resolution on the order of 10 parsecs, which may not sound like much. There's a lot of stars, nearer than 10 parsecs to the sun, but in terms of the entire galaxy, 10 kiloparsecs in size, that's a great resolution. So, all right, that's the background. So in 2012, this arc was used to measure a low mass galaxy, relatively low mass galaxy, only 200 billion times the mass of the sun. So not as hefty as our Milky Way, but still a reasonable, it may be a low mass galaxy, but it's still a reasonable mass. But in 2025, there was a group led by an astronomer named Powell who modeled a very small dimple in this extremely thin arc. And that's really what it looks like in the image they make, that there's just this little dimple, and the only way they could explain it, or well, the best way they could explain it, was a 1 million solar mass object tweaking the arc and producing this very small dimple. So redirecting some of the light. And this could be a very small galaxy or a failed galaxy, a lump of cold dark matter without any stars, or it could be a black hole, or it could be some combination of all the above. And so that was last year. And then just this year, at the start of this year, there was another paper led by a group called, by an astronomer named Vighetti. But what caught my eye is that the second author of the paper is one of the big proponents of cold dark matter. And so for them to be on a paper saying, well, this cold dark matter may face a challenge here is really interesting. And what it boils down to is that this little dimple in the arc, the inferred shape, if you will, or mass profile to be technical, the shape of this million solar mass object is hard to reproduce with cold dark matter models. So cold dark matter tends to have a certain shape. But in this case, they find a unresolved component, about 20% of the total mass. That's okay, that could be a black hole. But then the rest of it is sort of a uniform density face on disk of about 140 parsecs in radius. And that's what's difficult to match with cold dark matter. Cold dark matter can form objects that, or form clumps that small, but they wouldn't be uniform in density. And so this model has an overall size and mass that's consistent with what are called ultra compact galaxies that we found in the past decade or so, or local nuclear star clusters of dwarf galaxies. But those ultra compact galaxies and star clusters tend to be a lot more concentrated than this uniform mass density. But there is a theory which may fit better, and that's called self-interacting dark matter. So it's a theory, just as it sounds, in which dark matter has interactions with itself. So dark matter normally we think of in the cold dark matter model as being essentially collisionless. It just flies around and interacts with other things due to gravity, but almost never interacts any other way. It's what we call weakly interacting. But self-interacting dark matter, because it can interact with itself, it can result in more variety in the properties of dark matter halos and maybe even black holes made out of dark matter. So that theory might be able to explain this uh, mass profile that distorts this gravitationally lensed arc in a tiny way, but that, small uh, observation that is hard to explain in any other way, this could be the first thread that leads to an unraveling of cold dark matter and replacement with self-interacting dark matter. So the last thing I'll say about this is that this sort of gravitational imaging, as they call it, to produce a map of what the mass in an object looks like because of gravitational lensing. It's only the third case of that being done. But one of the other two is also highly concentrated. And the paper on that object was co-authored by former York undergraduate and astronomy major, Sophia Gad-Nazar. So I did not know about that York connection going in, but it's lovely to see. So has the full range of possible model parameters been tested? Maybe not. Maybe this will just be a flash in the pan and it will go away. Or maybe it's the, first hint of something big. So stay tuned.
Yeah, it's always interesting how these things start off as there's kind of these questions asked, and there's a number of papers that, take different tacks on it. And, it's the ideas seem to percolate around for a few years until they manage to get, more observations and sort of streamline things. But it's always interesting when you're, going back through papers to find sort of previous stuff, how you get this kind of process where, everybody has their own ideas and they eventually sort of converge. Some fall off, some get expanded, some get adjusted. And it's always interesting to kind of see these things happen in real time. And I think in astronomy in particular, as the technology gets better and better, you really see this happening, I think, more than you do in some other disciplines, because as the computing power increases and the observational power increases, you see this kind of process going on um, much more frequently than you might in sort of other disciplines. So
It's true. And it's not common to find radio lenses like this one, but you could observe this lens with maybe higher resolution at higher frequency and put even stronger constraints on what's going on, or maybe find that, some other combination of parameters is able to explain it just as well or even better. I'm very interested to see where this goes.
it's always interesting to follow some of these things along too, as it all develops. So so in the next little segment I have, happy Groundhog Day, everyone. As if you are following the news, of course, Wyerton Willie was rudely awakened earlier this morning to discover he didn't have a shadow. So they are telling us it will be an early spring. But like, where does this idea of Groundhog Day come from? And I'm not talking about the Bill Murray movie, but I mean, Groundhog Day is something that has been around for quite a while. The groundhog stems back to some earlier European traditions. But this particular day, February 2nd, actually has some astronomical ties. So if you look at sort of the history of astronomy, a lot of our calendar is structured around movements of the sun and movements of the moon. We still talk about solstices and equinox, although in our modern life, they're kind of like, okay, yeah, it's the equinox today, and we move on to sort of the next thing. And other than changing our clocks around those times, we don't think about it very much. But if you go back, especially a century or two, to sort of a more pre-literate society, and before you had sort of detailed clocks, a great deal of timekeeping centered around the solstices and the equinox. And one of the things that came out of this is we came up with these days that are kind of halfway between a solstice and an equinox. And that's exactly what Groundhog Day is. It's sort of, roughly at the halfway point between the December 21st solstice and the March 21st equinox. So when you say, okay, after today, we're going to have 6 more weeks of winter, well, that's actually to some extent literally true because winter sort of officially ends, at least from an astronomical season perspective, around the 21st of March, which is about 6 weeks from now. So one way or another, winter lasts about another 6 weeks. And then you have this odd tradition that came in of observing groundhogs to see if they had a shadow. And there's a very long and tortuous history behind that. But the idea of looking at the weather, at this midway point of February 2nd, actually dates back to some earlier Christian holidays, and they used to call it Candlemas. And there was this idea that if the weather was bright and sunny, the cold of winter would be hanging in for longer, whereas it was more sort of cloudy and cloud cover, then the temperatures were more likely to warm up sooner, right? And then this got morphed into the whole Groundhog Day thing, but it originally starts with this timekeeping. And Groundhog Day is not actually the only one of these days. If you look at May Day, where you talk about like maypoles and all those kind of events that often happen, or you talk about Halloween, these are also points that are sort of roughly at that halfway point between equinox and solstice, right? And when you're timekeeping and you're timekeeping on the solstices and the equinoxes, this halfway point is sort of another time marker. So that's how you end up with Groundhog Day. That's how you end up with May Day. That's how you end up with Halloween or the old Celtic Samhain, because of this sort of timekeeping between solstice and equinox. Now, a lot of people don't think about this anymore, but in centuries past, these were quite important because you kept time by the sky. That's how you knew when to plant your crops because we were very much agrarian. So when did you plant? When did you harvest? So they were much more attuned to this kind of thing. And then you have these sort of dates. Um, now February 2nd has become Groundhog Day, where we pester poor rodents out of their holes, and Halloween we send kids running around in costumes knocking on door to door for candy. But if you look where they came from, they really do have a link to timekeeping and astronomical observations. And I've always been fascinated with kind of some of the history of this and how much we've kind of lost when when you kind of lose that, connection to sky observing and timekeeping. So.
Yeah, it's true. It's, of course, it's a lot easier if you're living somewhere where the skies are clear or clearer more often than not. But I didn't know of this connection in between halfway between solstice and equinox. That will make me a bit happier to see Groundhog Day come along every year, regardless of
Because it is
what the
only
forecast
six
is.
weeks till the end of winter at that point. And
Yeah, it's
basically 6 weeks to the equinox. And people don't put it together until you do a little reading. It's like, oh yeah, it is about 6 weeks to the 21st of March. So it is like 6 weeks to the end of winter, relevant of what the groundhog says. So it's kind of funny that way, but it's we don't need that kind of timekeeping anymore, so we kind of forget it. But the traditions are there and still get carried on into sort of other, I guess, modern day traditions. But it's always interesting to see that there is always this kind of sky observing tie to so many of these holidays. I mean, the other big one that comes up around this time of year, of course, is Easter. And Easter is always the first Sunday after the first full moon after the spring equinox. So, like our habit of keeping time by the sky goes back an awful long way. And that's why Easter always moves around in the calendar and isn't one set date because it's always based on full moons and equinoxes. So,
and is there a festival between the summer solstice and the fall equinox? I guess in
I,
early August?
there historically there have been.
Mhm.
But in modern times, that one for some reason hasn't really carried through. Um, Sometimes the term midsummer is applied to that rather like because you have June 21st is the first day of summer, and then September 21st would be the last day of summer. So there's sometimes that idea of midsummer, Midsummer's Eve. Remember Shakespeare? Um,
Mm.
but it's not quite, we've kind of lost that one in modern times. But if you look at some of the old Celtic calendar had it very much where you had what they called the cross quarters, which were halfway between the solstices and the equinox. And I think they tagged that summer one as midsummer. Um, so Midsummer's Eve in Shakespeare and stuff. But that one seems to be a little less clear. And I'm not entirely sure why. We seem to have lost that one, whereas Groundhog Day and May Day and Halloween seem to have sort of maintained a cultural presence, whereas that one seems to have kind of disappeared.
Yes, in Canada, we seem to replace it with a bland August civic holiday.
I don't know, it's changed names. Do they still call it Simcoe Day? I don't know. It seems to change name every few years.
Yes, but I think the point of needing a holiday, recognizing that, oh, every once in a while we need a holiday. Now we can do it by one a month or so, but making a holiday halfway between on the solstices and the equinoxes, and then halfway between them, that sounds about right to me.
Yeah, I mean it's an easy way to time keep, right? So many of these things, they had practical applications. We don't know them anymore, but yeah. So Um, yeah, but and so many of these, it's like you can track them not just in Western, um, not in just in sort of Western calendar keeping, but you can see in other cultures as well, anywhere where you observe the solstices and the equinoxes to a fair degree. They're often something similar, right? Because that's how
Yeah.
you time kept. So
And you mentioned that we don't, need this timekeeping anymore. And it's true, we don't for actual timekeeping, but certainly I've noticed just in the past couple days when it's been a bit sunnier than it had been a few weeks ago, just the light changing and being a lighter a little earlier in the morning and a lighter a little later in the evening, and recognizing that is very reassuring to know that the seasons are changing and the days are getting longer.
oh yeah, I mean it, we're so light based in our sort of whole circadian rhythms that you do
Mhm.
notice it. It's just I don't think we pay attention to how that actually, we don't think so much, but yeah, sunrise is 2 minutes earlier today than it was yesterday. It's just all of a sudden, oh, look, I'm
Yeah.
getting up and it's light out now.
Yep. Yep.
So, oh my God, it's getting light out earlier and the dog is waking me up earlier.
Yes. Well, perhaps we can have a future episode about the about daylight saving time and why that might not be such a great idea.
No, and it's bizarre how some daylight saving time to some extent even came around. Like they talk about it as a wartime measure to save electricity or something, but from what I've read, the history isn't quite that clear. And once we got stuck doing it, they just kept doing it. And
Yes.
and every year, of course, when it happens, especially in spring when people have to get up earlier, the whole debate starts again about canceling it. And then after a couple of weeks, everybody's used to the new time and they forget it again.
Yes. Or you can, have the very sensible people in Saskatchewan and Arizona and Hawaii don't bother to go on daylight saving time. So,
I think Europe has moved away from it too at this point.
ooh,
I think they have.
wow. All right. Well, good for
So,
them.
or they're just about to move away from it because, like, this is getting ridiculous.
Right.
I don't
Well,
need this anymore.
speaking of Europe, that's a perfect segue to our next item that I wanted to talk about. And that's the good news of a cancellation of an industrial complex that had been planned near the Paranal Observatory in northern Chile. So this was an ESO press release. The European Southern Observatory that runs mini telescopes in Chile for a consortium of European and Chilean and Australian astronomers. So this was the news that a subsidiary of a US company known as AES Andes announced last Friday, or actually a week ago Friday, that they had decided to discontinue a green hydrogen and green ammonia project that they had planned for northern Chile. And the reason that this is good news is that a detailed analysis by ESO last year revealed that this project called INA would have caused severe and irreversible damage to the dark skies of Paranal, which is home to the very large telescopes, four of them, 8 meters in diameter, the VLT interferometer, which has those four telescopes working together as an optical interferometer, and the under construction extremely large telescope, which when it has first light will be, I believe, 39 meters in diameter and eventually 42 meters in diameter. And this damage would come in the form of light pollution from this giant industrial complex located too close to the observatories, micro vibrations that might even be felt through the ground, enough to cause problems for this interferometer, for example, and then increased dust, which spoils, causes what we call extinction, meaning there's just less light reaching the telescopes, and an increase of air turbulence in the area, which very still images lead to better resolution. So this was just not a winner from the astronomy point of view. And the press release mentioned that ESO and its member states are, of course, fully supportive of energy decarbonization and initiatives for a sustainable future. And green energy projects like this one and other industrial projects that drive development are very compatible with astronomical observatories if the different facilities are located at sufficient distances from one another. And the issue with this was not what the project was doing, just it was its proposed location. And therefore, ESO is working to establish protection measures for areas around their astronomical observatories, because these skies, and if you are a fan of astronomy and ever get a chance to travel to Chile, I highly recommend it. There is astrotourism available in northern Chile, and it's a very lovely region of the world, just from the deserts, the spectacular deserts, the salt flats, the llamas and guanacos, and alpacas you can see out there. But anyway, the ESO consortium will continue to lobby for protection of these facilities and also the broader fight that we're facing around the world against light pollution and satellite interference. I mean, it's one thing to say, oh, cool, look, a satellite, but another to have, arrays of satellites streaming across the sky nonstop. And so this is a bit of good news in that fight.
Yeah. As I said, the whole light pollution question is such a troubling one. I mean, how close was this facility supposed to be to some of these telescopes? So how big an area are they trying to protect?
Well, I don't recall the distance off the top of my head, but part of it is that when you're situated on a mountaintop, you have a wide view. In other words, you can see quite a long ways. So even something that might look on a map, oh, that's nowhere near close at all. But if it's a 24-hour facility running, as this one was proposed to be, with floodlights to illuminate, the
Mhm.
equipment at night, that might be on essentially a direct line of sight to the observatory, or close enough to a direct line of sight that it's a measurable and significant degradation. Um, these observatories are located relatively far from major cities, but the cities are still there and their light uh, pollution is an issue. And so in Tucson, Arizona, for example, and other communities near the Kitt Peak Observatory and others, they have lighting legislation that says, well, you can't just put any light you want up in your yard or in your business, you have to obey these restrictions on shielding that directs a light down to the ground, which is where you want it to go anyway. So it's not really that big a deal. Um, but yeah, I don't remember the distance exactly, but it was close enough to interfere significantly, even though on a map it may have looked like a large distance away.
Yeah. I mean, it can't, it's like I said, it can't physically be that far if you're talking about micro vibrations. Because, I mean, if it's low enough frequency, it would travel farther. But, you still have to be fairly close by to have like measurable vibration coming from these things. So it's kind of, I found it interesting. You talk
Yes.
about the light pollution, but it's also the dust and the vibration and
Yeah.
the air turbulence.
Yes.
I mean, the whole point is siting it on top of these mountainous regions is the air mass is so stable, it makes for great observing. But if you have something that's starting to disturb that, it kind of wrecks the whole, it wrecks the observational thing from more than one point of view. So, but it's like I said, they said it's light pollution and satellites are becoming a big headache for astronomers. Like I've seen the Starlink train pass overhead. The first time I saw it, I'm like, what the hell are these things? And my husband came out and says, "You dummy, it's the Starlinks." And I'm like, we sat there for about 15 minutes just watching this go by, and I'm like, God, that's like I can't believe how many of them there are up there. And like now, doesn't Amazon have one launched, and there are other people launching their whole galaxies? It's yeah,
Yeah.
it's getting crowded.
Yeah. And a quick look shows that this is much closer than I thought, only 5 to 11 kilometers away. So you know,
That's
that's
like
nothing.
really close.
Yeah, that's really close. Um,
You
so
tried to
yeah,
build it somewhere remote so this wouldn't happen.
exactly. And, Chile is blessed with an abundance of resources, that will be very useful for a sustainable future. But as Isod said, citing these in locations that are mutually agreed upon to allow both admiring the beauty of the night sky and the amazing discoveries we can make in them, and also uh, mining the minerals that we'll need for a green transition. Well, they can both be done if they're done planned in a mutually agreeable way.
Yeah. Because I mean, there are probably far fewer optimal observing locations around the world, like Chile, um, as opposed to places you can site a green energy plant. I mean,
Yes.
I mean, and the money has already been heavily invested into these telescopes, so it's really difficult. I mean, you basically destroy the abilities of these telescopes if you sight this thing too
Yes.
closely. Yeah.
Paranal is the darkest of the sort of top 30 observatories around the world. It's located in northern Chile for a reason. Well, for several reasons, but yeah, I'm very glad to hear that it's uh, going to avoid uh, contamination by this project. And hopefully a dark sky preserve will be initiated around it to protect it from future issues like this.
Yeah, it's one of the few wins astronomers get. Yeah. We lose out more often than we win by far when it comes to these kind of battles, unfortunately. So maybe
Yes,
we'll have to move all the telescopes to the far side of the moon.
yep. I resisted putting up a light on the number in front of my house for the longest time, but when I did, I made sure it was directed completely downward, so at least it's not polluting the sky.
Okay. Well, we've about come to the end of our time. So thank you for joining me tonight, Pat. I think we had a very wide-ranging discussion tonight.
We did. I will say there's one more topic that we didn't get to, which I'll bring back for next week or the week after. That's blue straggler stars, study by Hubble. It was announced in the uh, social media for tonight, but we didn't get to it.
So thank you all for listening. You have been listening to the York Universe podcast, our weekly podcast in association with our online public viewing. So thank you for joining us tonight, and we hope you will be listening again to future podcasts.